Alright, welcome back. CIS-332. This was week 4, last week. The week we just finished. Okay, on Monday, the data stored in a database is often referred to as persistent data. You know, like if my birth date is stored in a database, people can pull it out, use it, manipulate, and so forth, but it stays persistent. It's a piece of data that doesn't typically change. Now, that doesn't mean the values can't change in a database, but they're persistent there. Input and output, those aren't part of the database. You know, we can, from the outside in, we can put information in, and from the inside we can take information out. It's not considered part of the database. We build databases based on relational database based on entities or tables, and then we develop characteristics about the entity, which we call attributes. And then later on we talk about the attributes. We break down into a certain type, and then some specific things like key and foreign key and so forth. Some things that databases do for us, not necessarily why, but reduce redundancy. It can manage the data, sort, query, update, share the data. Avoid inconsistencies. Data is all stored, it's persistent, it's in one place, stored on the hard drive or wherever. We can follow standards. Security was the issue. We can do a better job of retaining the integrity of the data and balancing conflicting requirements. I gave the example, if you're doing a database on a school and somebody said grade, there could be a conflict in what that means. You know, if you're talking about like in elementary, people talk about first, second, third grade. Typically in high school, they're talking about A, B, C, and first, second, third, so forth. All right, we're going to move on to the next page. Data dependence depends on the code. You know, the software writes the data to the disk, and you have to understand how it does that if you're going to write anything to take it off the disk. Data independence means that doesn't exist. You use some database management system to write the data, so the data is independent. It's independence. It's not dependent upon the code. It's not dependent on the code. We've been working on a population example, one entity at this point. And all the different attributes coming off of that entity. Who uses databases? Application programmers, end users, database administrators. I mean, you could probably split out then these maybe other ways, but in general, okay, we have a database administrator and those people that work with them to create and maintain the data. We have programmers that design apps that may have to use the data, and the administrator in between here makes sure that all works and that this is secured and the integrity is good and so forth. So the people coming in from the outside tends to be external, how we design the logic, and then the database system actually writes the data to the physical drive. I'll probably review this again, but we talked about top-down design, and there is a lot to this, but if you're going to design, let's say, an information system, some management information system, you have this, you're going to have a big pool of data, and then you're going to design these different levels of information that need to come out of that data. The first thing you have to do is analyze. And there can be lots of charts, diagrams, and so forth. You have to understand what data needs to go to who and for what reasons and when and so forth. Once you get all this work done, you get data flow diagrams and flow charts and so forth. Then you can go in and really design the database or the information system, but here we're going to talk primarily about databases. This is referred to as feedback loops. You come up with part of a design, you get it approved or not approved, change it, and so forth. Once you get it all designed, then you can go in and actually develop it. In our case, for databases here, you can start actually making tables. You know, you start actually doing the work, implement, and evaluate. And there's a loop back here. Hopefully this feedback isn't too big at this point, because you should have taken care of, as you worked your way through, you should have taken care of a lot of the possible errors before you actually start developing it. Alright. So, just went through this: analysis, design, development, implementation, and evaluation. So, in the database part, this would be the conceptual view, the analysis, and all the different items there. Then it moves into the design, which would be the logical view. There we would start, you'd create entities, then attributes, then you would define the type for those attributes, and so forth. Like here we have attribute, data element, attribute, and then these would have certain type. This might be text, this would be date, and so forth. And then we reviewed the system development life cycle. We reviewed that on Wednesday. Then we said how this falls over to here. We have a conceptual view when we're going through the data model. Then we have the database logical, and then the database physical, the actual database, and we're using MySQL. Users look at it from here, and us in designing it, we're working right in here, and we let SQL actually store it. Here's a little representation again of maybe the internet. And from some source we can access a secured website which gets the data out of the database, gets it back, sends it back to us. A couple more things to cover. We talked about entities. So in the conceptual view, when you're creating a database, you end up determining what the entities are going to be. Then you develop the characteristics about each of those entities. You start developing attributes. Once you start developing attributes, you look at constraints on the attributes. What type? You know, what constraints, if it's going to be a key, or they have to fit within a certain range. Constraints. Then the type, you know, is it a number? Is it text? Is it a date? All the different things. Data description, we talked about data dictionary. We also, in a data description, you can talk about data definition language or the data description language. Sometimes it's referred to that in terms of the syntax that you use to design these. We're using MySQL. So there's actually two ways you could look at that. One value for the attribute, multiple values for the attribute. Attributes can have a single value, or a multi-value attribute can have more than one value at a time. Composite contains two or more attributes. One last thing to cover. We can have primary keys and foreign keys inside our tables, and then rebuild relationships between those. And those keys can have a restraint on them, like a primary key. Primary key cannot be null, has to have a value. Now, null typically is referred to there is no value, whereas sometimes not available is referred to as you just can't get the value. So when people say they have missing or unknown values, that would be more like this. It's not available. If it's null, there just isn't a value for it. It's for that particular person, there's no value for it. All right, that ends the review for week 4.